Now let's talk about special right triangles. There are two special right triangles, and you really should memorize these. So let's draw them right here. First one we have is a 45, 45, 90. I'm going to label it 45, 45, 90. First thing about this triangle, the legs are the same length because it's an isosceles triangle because you have two angles that are the same. And for this one, how I used to teach these is the magic number for this one is square root of 2. Now what that means, if we think logically, multiplying or dividing. If I want to make something bigger, am I going to multiply or divide to make it bigger? Well, multiply. Multiplying makes things bigger, dividing makes things smaller. So if I have a larger side going to a smaller side, I'm making it smaller, so I will divide by my root 2, my magic number, to make it smaller. If I start with a smaller side, and I'm going to a bigger side, I'm making it bigger, so now I will multiply by my root 2. So let's say you have a problem, they say the hypotenuse is 5, and they ask what the sides are on this 45, 45, 90. I want to get to a smaller side, so the smaller sides would be 5 root 2, 5 over root 2. Or, you can go the other way. Let's say they tell you the legs are 3.2. Then, I want to get to the hypotenuse, I want to make it bigger, so I'm going to multiply by root 2. And that's how the pattern works for the 45, 45, 90. No matter what the number is, you multiply or divide by root 2 to get from the legs to the hypotenuse. Next one is our 30, 60, 90. 30 degrees. This one has a couple different patterns you need to know. The first one is between these two sides. And the magic number for those ones is 2. If you ever forget that, one thing you can do is reflect this triangle across. And notice, if I reflect it, I now have an equilateral. 60, 60, 60. Which means this side is going to have to be half of the longer side because of that equilateral. So then you can remember that magic 2. Divide by 2 if you want it to be smaller, multiply by 2 if you want it to get bigger. Then to go from this smaller side, the magic number there is root 3. Now there is a pattern between these two sides, but you don't actually need it. And why memorize more patterns than you need to? So for example, let's say I know this long side is 2. Well, to get to this shorter side, I would multiply by 2 because I'm getting bigger. And, oh nope, I did that wrong. Sorry guys. I would divide by 2 because I'm getting smaller from a big side to a small side. So I divide by 2, get 1. Then I want to get over to this longer side. Now I'm getting bigger, so now I multiply by root 3. And I can find all the sides. Let's say they give you, start out with this one in the middle, and this one's 5. To get to the long side, I multiply by 2, because I'm getting bigger, so I multiply. And to get to this side, I am also getting bigger, so I also multiply. I can still find all 3. Last option, let's say they give you this side. I want to find the shorter side first, so I will divide by root 3, because I'm getting shorter. And once again, you do not need to simplify or rationalize that. You can leave it be. And then multiply by 2 to get that last side. So no matter what side you're given, you can find all of them using those rules. Now let's talk about reference angles. We'll do these two. I can also use these to find lots of other angles. So this one I want to find the cosine of 210 degrees. So if I label this coordinate grid 0, next one will be 90, because it's a 90-degree angle. Next will be 180, 270, and then all the way back around one full circle is 360 degrees. I would memorize those. 210. What quadrant is it going to be in? Excuse the bell. So I need to think, what quadrant is 210 going to be in? Well, 210 is going to be in quadrant 3, because 210 is a little past 180. Then I can draw this right triangle here and make this angle right here. That is called a reference angle. A reference angle is any angle back to the x-axis. So if you are above the x-axis, the reference angle is down to the x-axis. If you're below the x-axis, the reference angle is up to the x-axis. And I want to find what is that reference angle right there. Well, I can just find the difference. 210 minus 180 is 30 degrees. So this is a 30, 60, 90. And not only that, this is on the unit circle. The reason it's called the unit circle is because the radius is always 1. Always, always on the unit circle. So now I can use my 30, 60, 90. I'm from the long side to the shortest leg, so divide by 2, 1/2. And from the shortest leg to the longest leg, times by root 3, because I'm getting bigger, so root 3 over 2. And that's where those numbers on the unit circle come from, is from those special right triangles. One last thing that I need to add to this reference triangle. This is in quadrant 3, which means in quadrant 3, everything's negative. So I'm going to add negatives in front of both of those numbers. Now let's go back to the problem it asked. Cosine of 210. Cosine is your x over r. But for the unit circle, r is 1. So this is really just the x value, because we don't need to divide by 1. So the x value is negative root 3 over 2. And there we go. Okay, this one, 315, do the same thing. Where would 315 be? What quadrant? It looks like 315 is going to be in quadrant 4, because it's a little less than 360. And it's going to have a reference angle of 45 degrees. So this is my 45, 45, 90. The radius is 1, because it's the unit circle. Divide by root 2 to get to the shorter side. Divide. And in quadrant 4, my y's are negative. Tangent is y over x. So I take my y value, negative 1 over root 2, divided by my x value, 1 over root 2. You can leave it like that if you want. That's fine. This one does simplify really quickly, though, because if you think of negative 3 over 3, that simplifies to negative 1. So same idea here. That's going to simplify to negative 1. So that is your special right triangles and your reference angle.